Have you ever gazed up at the night sky and wondered whether we are truly alone? For centuries, humans have pondered this question, but only recently have we developed the tools to begin searching for answers. Alien life, meaning life beyond Earth, is one of the most fascinating and mysterious subjects in modern science. It challenges our understanding of biology, existence, and our place in the universe. When we speak of alien life, we are not necessarily talking about the green creatures from movies. Alien life can take many forms. It might be microscopic bacteria living in harsh environments, multicellular organisms adapted to extreme conditions, or even intelligent beings capable of complex thought, communication, and technology. Each form, whether simple or advanced, has the potential to reshape our understanding of life itself. Scientists employ several methods to detect extraterrestrial life. One of the primary approaches is studying exoplanets, planets orbiting stars beyond our solar system. Thousands have been discovered, and some are located in the so-called habitable zone, where temperatures and conditions may allow liquid water to exist. Liquid water, as we know it, is a key ingredient for life. The transit method is widely used to study these distant worlds. When a planet passes in front of its star, the star's light slightly dims. By measuring this dimming, scientists can estimate the planet's size, orbit, and even atmospheric composition. Radial velocity, also known as the Doppler method, tracks tiny wobbles in a star caused by gravitational pulls from orbiting planets. These observations help us identify potential candidates for further study. Direct imaging of exoplanets is more challenging but occasionally possible. Using advanced telescopes and specialized imaging techniques, astronomers can capture images of distant worlds, allowing for preliminary analysis of their atmospheres or surfaces. Additionally, gravitational microlensing and spectroscopy provide further clues about planetary environments. Even within our solar system, some moons are considered prime candidates for life. Jupiter's moon, Europa, and Saturn's moon, Enceladus, both have subsurface oceans beneath thick ice layers. These oceans could harbor microbial life, potentially hidden from our direct view, but detectable through future missions. Mars, with evidence of ancient rivers and possible underground water reservoirs, remains another key target. Discovering even microbial life on these bodies would have monumental implications for our understanding of biology and evolution. The search for alien life extends beyond planets. Unidentified flying objects, or UFOs, have been reported worldwide for decades. While most have plausible explanations, a few sightings remain unexplained. Stories such as the Roswell incident continue to spark public imagination. Even if these are not scientific proof, they reflect humanity's long-standing curiosity about life beyond Earth. Scientists categorize potential alien life into three main types. First, microbial life, tiny organisms that could survive in extreme conditions. Second, plant-like or animal-like life, which may share structural or behavioral similarities to earthly life but remain adapted to alien environments. Third, intelligent life, capable of advanced thought, communication, and technology. Each category requires distinct strategies for detection, and each carries different implications for humanity. Discovering alien life would have profound biological implications. It would suggest that life can arise under various conditions, offering insight into the principles of evolution and adaptation. Chemically, it could reveal alternative biochemistries, expanding our understanding of the possibilities of life. Philosophically, it challenges our human-centric perspective of the universe, prompting reflection on the uniqueness, or lack thereof, of life on Earth. Culturally, alien life could inspire stories, art, and media, reshaping our imagination. Education systems could incorporate new concepts about biology, evolution, and the cosmos, encouraging a generation to think beyond Earth. Even the smallest forms of alien life could provoke global discussions about ethics, exploration, and the responsibilities we hold towards other living beings. Technologically, humanity would experience a surge in innovation. Space probes, robotic explorers, and AI-driven data analysis will play crucial roles in studying these distant worlds. Learning from alien biochemistry or environments could even inspire new approaches to medicine, energy, or communication. Ultimately, the search for alien life is not just about discovery, it is about understanding life itself. Each new finding challenges assumptions, inspires curiosity, and broadens humanity's perspective. The universe is vast, and the possibility of life beyond Earth is a powerful reminder of both our fragility and our potential. As we continue to explore distant planets, moons, and exoplanets, humanity stands on the threshold of what could be the greatest discovery in history. Understanding alien life may redefine biology, philosophy, culture, and our place in the cosmos.
The discovery of alien life, whether microbial or intelligent, would be transformative for humanity. Even simple microbial life found on Mars, Europa, or elsewhere would prove that life is not exclusive to Earth. This would trigger a revolution in biology, offering insights into life's origins, chemical pathways, and evolutionary patterns. If these organisms use entirely different biochemistries, it would challenge long-held assumptions about DNA, proteins, and the universality of life. Intelligent alien life would have even greater consequences. Humanity would face profound ethical and philosophical questions. How should we approach them? Do we attempt communication or observe quietly? Could intelligent aliens pose a threat, or would they share knowledge? These questions would demand new global discussions involving scientists, philosophers, policymakers, and ethicists. Religious and spiritual frameworks would be challenged. For millennia, many belief systems have placed humans at the center of creation. Confirmation of alien life might require reinterpretation of sacred texts and doctrines. Some may view extraterrestrial life as part of divine creation, while others may struggle to reconcile their beliefs with this new reality. Socially, humanity could experience both unity and tension. On one hand, realizing we share the universe with other life forms might foster global cooperation, a shared identity, and a sense of cosmic perspective. On the other, fear, skepticism, or political competition could emerge, particularly if intelligent life is assumed to be technologically advanced or threatening. Technologically, the implications would be enormous. New spacecraft, rovers, and exploration tools would be needed to study alien life directly. Artificial intelligence could help detect and interpret subtle signals from other worlds. Biochemistry and bioengineering could benefit from learning about alien organisms, potentially leading to breakthroughs in medicine, energy, and sustainability. Ethically, humanity would face uncharted territory. Should we grant rights or protections to intelligent alien life? How do we avoid contaminating other worlds with Earth organisms? International laws and planetary protection protocols would need to evolve rapidly, balancing exploration with responsibility. Politically, nations might compete or collaborate on a global scale to study and interact with alien life. Space exploration could become a shared mission for all of humanity, encouraging cooperation and uniting people under a common purpose. At the same time, it could spark disputes over resources, territory, or technological advantage. Culturally, discovering alien life would influence art, literature, film, and media worldwide. Public imagination would be fueled, education systems would adapt, and future generations might grow up with a broader understanding of life in the cosmos. Philosophically, discovering alien life forces us to reconsider fundamental questions about consciousness, intelligence, and existence. Are humans unique, or is life an emergent property of the universe? Even microbial life beyond Earth suggests that life is not an isolated phenomenon, but a natural outcome of certain conditions. Practically, discovery would influence space travel and colonization. Humanity must ensure we do not harm alien ecosystems. Containment protocols, sterilization procedures, and ethical guidelines would become critical in every mission. Ultimately, finding alien life represents more than a scientific milestone. It is a cultural, philosophical, ethical, and existential awakening. Humanity would need to rethink its place in the universe, adapt to new knowledge, and prepare for the long-term consequences of knowing we are not alone. The search is ongoing, and every discovery raises new questions. Human curiosity and the desire to understand the universe will guide us as we explore these mysteries. Alien life, whether microscopic or intelligent, expands our perspective, challenges our assumptions, and invites us to imagine a universe far richer and more interconnected than we have ever known.